As a test engineer, you receive requirements all the time, and they're not necessarily all the same kind. Each type carries a hint about how to test it, the method, the infrastructure, the evidence you need to produce. This video is about the main requirement types someone will meet as a test engineer in system test, so like the functional versus non-functional requirements, the level of requirements, their source, etc. The first and most important split is functional versus non-functional requirements. A functional requirement describes what the system does, its inputs, outputs, the behavior, and the state changes. For example, on a button press, the system shall log the event and switch to some kind of mode. A non-functional requirement, on the other hand, describes how well the system does it. So the performance, reliability, usability, and concerns about security and maintainability. To test these, often you need specific test infrastructure and test methods, like load generators, climate chambers, or stress test abilities. And there are constraints, like boundary conditions, that are crucial for testing. The key point here is that the requirement type changes the test method and in general the way of testing. Another way to look at requirements are the level they sit on. A system requirement describes the product as a whole. This is the main level system test operates on. Below that, there are subsystems and component requirements, usually covered by integration and unit tests, but they still shape what arrives and is important for system testing. Interface requirements describe how system tests talk to each other. In complex systems, many defects live exactly here. Above the system level, there are also the stakeholders or user requirements. So what the customer or operator in the end expects. So keep in mind on what level the requirement sits on and which approach for testing should be taken here. Requirements also differ by where they come from. Customer or business requirements come from the market, a contract, or the product owner. Then there are also standards or regulations as another source, safety norms like ISO or other regulations. These are often mandatory with strict rules about the evidence you must produce. Internal or derived requirements are engineering refinements. Each one should trace back to a parent requirement. The key point is that source decides how strict your traceability has to be. There are also some special categories which deserve attention. Safety requirements are tied to hazard analysis, like fault tree analysis or FMEA, and demand coverage, traceability, and deliberate fault injection. Security requirements call for abuse cases, penetration tests, and fuzzing. Environmental requirements cover temperature, vibrations, or EMC. Operational requirements describe startup, shutdown, or recovery procedures. Diagnostic and serviceability requirements cover logs, error codes, and service interfaces. So what does this mean in practice for system test? Each requirement type implies a method, an infrastructure, and an evidence level. Functional requirements call for behavior tests, while non-functional requirements call for tests like load testing, stress tests, or similar. And then there are safety requirements, which emphasize the traceability and a need for fault injection or other special test methods to ensure safety. The infrastructure ranges from a standard test bench to a climate chamber or audit-grade traceable setup. As a test manager, you have to pick the right test methods and the right way of testing to cover the requirements properly.